day, everyone. I hope you're all good. It's been quite some time, yo. I think it's now about a month. We were all on holiday. I hope all the June exams went well with you. So what we're gonna do today, we're gonna do all the memo for June exam paper two. And this coming week we'll be doing the memos for physics as well as technical maths, just technical sciences. And yeah, I hope you are all enjoying wherever you will be watching us from. Please make it a point that you subscribe if you are not subscribed. If you have not yet subscribed, you comment, you share, then we can be able to assist each other. Please don't forget to drop your questions on the comment section or in the description of this video. You can join our WhatsApp group so that you can be able to receive our material. You can be able to interact together when you have a question. Anytime, any moment, you will be able to be assisted. So today we'll be doing the full memo for this question paper two, which you wrote in your June exams, which was quite nice, I think, because we had covered everything in the paper. But let's just do the memo. So in the group, also students were asking for us to look at trigonometry as well as Euclidean geometry first. So today we're gonna look at the section of trigonometry and Euclidean geometry. So if you have any question, don't hesitate to ask us. We are here to assist you. We are here to help you and work together with you. So as you can see, this was your paper which you wrote in your June exam. You can see that it was quite nice. I think it was quite nice. So please share with your friends that it's about to go down now in the preparation for your trial exam. Let's start with your June exam and let's reflect on that. Now, as you can see, this is our June 2023 paper which we wrote this year. It was paper two, so we're gonna start with paper two. So you can see it had 10 questions. Of course, there's statistics, which is always 20 marks, of course. Then we have our analytical geometry, 40 marks, oh my word. And we have now where we are starting today, our trigonometry. So in trigonometry, guys, at this point, you must be able to realize that what's important is to understand your reduction formulae, to understand which quadrant is which trig ratio positive, which quadrant is which trig ratio is positive. So we have three trig ratios which we focus on when we are looking at pure maths. We have sine, we have cos, as well as tan. So those three are the so important trig ratios which we are supposed to always consider when we are looking at our pure maths. Now it's very important to understand that in these three trig ratios we have what we call identities, which we have been taught last year in grade 11, and we also have our double angles and our compound angles which we were introduced to in grade 12. To be able to do or to be able to know those things, and also our double identities, those are so important. They are 2 cos 2 theta and sine 2 theta, to be able to express them. I also love the fact that they are on your formula sheet. Let's go to the formula sheet. Sorry. Okay, yes, you can see here we are. You can see that, yes, from this point here we can see that, oh, okay, this is what we are actually doing right now. So this is when we're looking at 2D and 3D last year in grade 11. Now we have sine rule. This is the formula for sine rule. This is for cosine rule. This is the area rule. Then, of course, this is our compound angles, which are so important. These four are our compound angles. We must always know all these compound angles. Then we have our double angles, which are this one, cos 2a, which is equal to these three, and also sine 2a, which is equal to. So actually we have everything we need at our disposal to be able to write and finish this paper. You don't have to cram them, you just supposed to know how to use them. As you can see that they are already available for you on your formula sheet. Now, without wasting much time, let's dive to what we want to do today, trigonometry. Now, question number 5. Question number 5. So we are given if 5 cos theta minus 3 is equal to 0 on that specific interval from 180 to 360, then we are also given 17 sine alpha equal to 8 at that specific interval. Determine without the use of a calculator the value of tan A plus tan theta. Oh, this is so great. So now we are looking at the coordinate system, which we have done in grade 11. So now let's write this down first. So we are given that if 5 cos of theta minus 3 is equal to 0 at this interval 180 less or equal to theta less or equal to sorry, it's not less or equal, so it's just less than theta. and less than 360 degrees. Then we're also given 17 sine of alpha equal to 8 on this interval, 90 less than alpha less than 270. Now let's solve this. So they want tan alpha plus tan theta. Now let's do this fast, quick, and out. This is 6 marks, so we must supposed to spend 6 minutes. But since we are now good at what we do and now understand the concept, we don't have to spend the whole 6 minutes. At least if we spend maybe 3 minutes, that would be great. Now let's solve this together. The moment you see this, what's supposed to come to your mind is to be able to draw these different this on the coordinate system and this. So this is where the main marks should be. Okay, so for 5 cos theta, so we can now go down and say 5 cos of theta minus 3 is equal to 0. Then therefore cos of theta will be equal to 3. We transpose this 3 to the other side, then it will be positive 3. Then this 5 is multiplying. So when we transpose it, it will divide. So now we have cos of theta equal to 3 over 5. Now we were given the interval from 180 to 360 degrees. So when we draw our reduction formula, we know that only cos is positive in the fourth quadrant. Okay, of course, because you can see that we have cos of theta, which is equal to 3 over 5, which is positive. So, which means it's positive in the fourth quadrant. So, we should be able to draw our thing in the fourth quadrant. Okay, so let's draw this thing first. So, this will be something like this. Okay, then of course, this is our theta here. Then this is our 3, this is our 5. So, we must know the value of y here. Okay. Then, of course, let's just draw 2 of them. Then another one we were given 17 sine alpha equal to 8. Of course, we just divide by 17. Then we have 7 sine of alpha equal to 8 over 17. Of course, then we are done on that part. But we are given the interval from 90 to 270. So when we are drawing our quadrant, we should know which quadrant is uh, we will sign positive. We know that sign is positive in first and second quadrant. First and second quadrant. So this is already easy for us for the fact that they have told us it must be between 90 degrees and 270 degrees. So where else is sign positive? Sign is positive in the first and in the second quadrant. So in this instance, since it's starting from 90 going forward, which means our next triangle will be drawn in this quadrant here. So we have it. Of course, we know that sign. Let's do this. Okay, here we go. Do this. Yeah. Okay. So we can see that our triangle is going to be in this quadrant. Then, of course, 17 is the hypotenuse and 8 is, then we need to look at x. So, of course, we know our Pythagoras theorem. So now let's calculate the missing. We know that r squared is equal to x squared plus y squared. Okay. Then after that, of course, we know that our r squared in this instance was 5 squared and our x is 3 squared plus y squared. Now we calculate y, then y will be equal to square root of 5 squared minus 3 squared. Then we get the value of y. Use your Casio calculators, okay, always, so that you can be accurate. So 5 squared minus 3 squared, that will be 4. Okay, so our y value is equal to 4. But you can see that this is the side where y is negative. Okay, so which means this y is going to be negative 4. Okay, so those are the interpretations which are important. Now let's look for the value of x here. Of course, again, r squared is equal to x squared plus y squared. Okay, then of course our r squared is 17 squared equal to x squared plus 8 squared. Then x will be equal to square root of 17 squared minus 8 squared. Okay, then our x will be equal to what? Again, we use our Casio calculator. So square root of 18 squared, 17 squared, sorry, minus 8 squared, that will be 15. Okay, then we have our x, which is equal to 15. And we can see that the x is on the negative here. So our answer will be negative 15, because when we draw our Cartesian plane, we know that upwards is positive and also this side is positive. So let me just do it. So something like this, this is our Cartesian plane. So we know that this is the x, this is the y axis. So this is the positive side. Y is positive, x is positive. This side now negative x, and this is the negative y. So it's so important to be able to depict that, and according to your Cartesian plane. Now everything is easy for us. The question was saying what is tan of alpha plus tan of theta. Okay, of course, that's already easy for us. What is tan? You know that tan is always opposite over adjacent. So in this instance, it's gonna be, where is alpha? Where are you, alpha? Here we are. Then our alpha will be 17 over negative 15 plus tan theta, which is also negative 4 over 3. Then after that, we use our calculators here. Okay, sorry. Oh, so I used 17, it's supposed to be 8. 17 is the hypotenuse. Let's use 8. So yes, this is the opposite over hypotenuse over the adjacent, then opposite over adjacent. Then after that, we use our Keshe calculator to find the correct answer. Then on my side, I'm getting negative 28 over 15. Then you are done. So this question was so long, but this question was so easy at the same time. Now let's move forward to the next question, which is 5.2. What do they want in 5.2? Let's check it out. Now, if cos 42 is equal to P, determine each of the following in terms of P. Bingo! That's great. So on 5.2, we are given cos of 42 degrees, which is equal to P. Okay. Now, again, in this question, we are supposed to draw the Cartesian plane, and we have our triangle. Okay. So, of course, this will be in the first quadrant automatically. And we know that cos is the same as adjacent over hypotenuse. So in this instance, it's P over 1. So it's P over 1. So if we say this is our 42 degrees here, which means here is going to be P over 1. So you should calculate the value of y. Again, we use our Pythagoras theorem to get the value of y. Then our y will be equal to square root of 1 squared minus P squared. So then definitely you can actually see that our y is equal to 1 minus square root 1 minus P squared. That's that. So this is the value of y, and we can see that it's supposed to be positive because we drew our triangle in the first quadrant, and in the first quadrant the y is positive and the x as well is positive. Then we are done. Now let's answer the first question. What is sine of 48? Okay. So before we go further, we should be able to fill the whole triangle with all angles. So the missing triangle 5.2.1. So let's say 90 plus 42 minus 180. So in other words, the missing angle is 48 degrees, okay? Because from Euclidean geometry, by now everyone knows that the sum of all angles in the triangle adds up to 180 degrees. Now we can proceed from that. So sine of 48 degrees will be equal to what? P over 1, opposite over hypotenuse. Then we are done. 5.2.2. 5.2.2, we need sine of negative 2202 degrees, okay, which is equal to what? Now this is just trying to confuse us, guys. Like literally they're just trying to confuse us. This is the same, you know that sine of a negative angle will always be negative, so this will be negative sine of 2202 degrees. Okay, so what I always advise is that choose your calculator. Okay, so let's reduce it until we get to an acute angle. Okay, so if you say reduce, and so it's 360, it's a complete revolution. 720 is a complete revolution. Then plus 360 until we reach here. So we'll be able to see that we have negative sine of 360 degrees plus 42 degrees, okay, at the end. So what is important is to understand the first revolution is 360, the other one is 720, the other one is 720 plus 360, then until it's 1080 plus 360 That's 1440 plus 360. Then we are 1800 plus 360. Then now we are 2160. Then if we add 42 there, we'll be able to get our answer. So initially here, before I just used 360, 360 is what we are used to. But here you could have used, let's just do this first. 216. Okay, this is the fifth revolution. Okay, a complete revolution is 360. So we are adding 360 plus 360 plus 360 plus 360 so that we can be near to the angle which we want. So this is the same as sine of 2160 plus 42 degrees. Then we can be able to get this angle. And of course, we know that this is in the fourth quadrant. So this is in the first quadrant, 2160 plus 40 is in the first quadrant. So then definitely now we have negative sine of 42 degrees. Then after that, sine of 42 degrees according to our triangle is the same as y over 1. So it's going to be negative square root of 1 minus p squared. Just like that, then you have your 2 marks. So that's big angle. They were just trying to confuse us, but please don't be worried. You have us, so everything is properly good. Now let's proceed to the next question. Next question says cos of 84. Wow, let's move on to that. 5.2.3. What is cos of 84 degrees? So we actually know that, oh, okay, this is the same as cos of 2 times 42 degrees. Okay, so 2 times 42 is 84. So we can actually see that that's a double angle. So everything already from this point is already easy because we now know our double angles. So I always advise people to use the double angle of cos alone. So it's going to be 2 cos squared of theta. In this instance, our theta is 42 degrees minus 1. Of course, we know that, guys, cos of 2 theta is equal to 2 cos squared of theta minus 1, or it can be 1 minus 2 sine squared of theta. It can be also cos squared of theta minus sine squared of theta. So those are the three identities which we found from this double angle. Now we can proceed and we can substitute 2. Then cos of 42 is just p, so it's going to be p squared now. So it's going to be 2p squared minus 1. Then after that, we have solved that question and we are all happy. So these questions were just almost straightforward. We just wanted to use our theory and use what we have already been taught in class. Now let's look at 5.3. Now let's look at 5.3. Sorry. 5.3. What does it want? Oh my word. Determine the value of the expression without the use of a calculator. The moment you use a calculator, you are already out. This is fantastic. Let's go for 5.3. 5.3, tan of 300 degrees plus cos of 90 degrees plus x divided by sine of 180 degrees minus x plus 2 cos of negative 30. Now let's do this fast. 6 marks, we say it is 3 minutes. Okay, now the first thing we do is we reduce that 300 degrees. So we need our reduction formulae. We know that all of them, they are positive. Only sine is positive, only tan is positive, only cos is positive. This is 180, this is 0, this is 270, this is 360 degrees minus, this is 180 degrees plus, this is 180 degrees minus, then also 90 degrees plus, this is 90 degrees minus, this is 360 degrees. This is our reduction formula. By now everyone knows this. Okay, so tan 300, where is 300? 300 is in the fourth quadrant, and we know that in the fourth quadrant we have tan of 360 degrees minus. So which one is the acute angle which we are looking at? So 360 degrees minus 300, you get 60. So it's going to be 360 degrees minus 60, then plus cos of 90 degrees plus x divided by sine of 180 degrees minus x plus 2 cos of negative 30. From that moment, I'm already feeling excited about this because now we can reduce it. Okay, now we go 360 minus is in the fourth quadrant and is tan positive or negative. It's negative. So now we have negative tan of 60 degrees. Then cos 90 plus is in each quadrant, it's in the second quadrant. 90 plus is in the second quadrant. And is cos positive or negative? It's negative. And we can see it's 90 plus and it's cos. And we know that at 90 degrees, cos changes to sine. So those are what we call co-functions or co-ratios. So now we have minus sine of x. Now we divide 180 minus sine 180 minus. So 180 minus is in the second quadrant and sine is positive. So that will be positive sine of x, then plus, of course, 2 cos of 30 degrees. Me and you, we already know that at 30, any negative angle, when we are looking at cos, is always positive, okay? So negative times 60, which means now we are looking at our special triangles which we have, okay? So your mind must be able to think fast, all right? So this will be for 60, then we have 30. That will be 1, 2 root 3. Okay, so now what is tan of 60? If you use your calculator, you will have another answer. So please be careful. Let's just do it now. So tan of 60, according to your calculator, is just root 3, which this one is going to be perfect. But when we're going to say tan 30, you're going to have root 3 over 3, which is wrong. Because when you use this, it should be supposed to be 1 over root 3. So in this instance, we have our negative root 3 minus sine of x divided by sine x. Then what is cos of 30? Cos of 30 will be 1 over root 3. Okay, so plus 2 1 over root 3. Then after that we can solve this problem because everything is already good for us. Okay, so we can actually see that, oh, okay, oh, sorry, it's root 3 over 2, not root 3 over 1 over root 3, because this is 30, so it's gonna be adjacent over. So you can see mistakes are common. So make sure that you double check your work as you are also writing. So that will be root 3 over 2 there. Okay, as you can see, root 3 over 2. So this and this will cancel. Then of course we have root negative root 3 minus sine x divided by sine x plus 3. Now we can make the numerator also positive by saying negative as a common factor. Then we have sine x positive plus root 3 also, which is positive. We divide by sine of x plus square root of 3. So this and this will cancel. Then we are left with negative 1. So after that, you get your 6 marks. This was so long and so fantastic and so nice. Okay, let's move forward to the next question, guys. We don't have time. Now, prove the following. This is hectic. Prove the following question. So, in order for us to prove that, let's prove the left-hand side, okay? You can never prove both sides at the same time. So let's just say 5.4 left-hand side is equal to what? 1 minus sine 2x all divided by cos 2x. It's only 5 marks, okay? So you can never prove both sides. So you should choose which side you want to prove. So I want to prove the left hand side because you can see that we have double angles there. So we can play around with that so that you can be able to get at least a final answer from that. So from that, we can see that this is a double angle. So this will be 1 minus 2 sine of x times cos of x divided by 1. Then we have cos of 2x. And of course, this is also a double angle, but you must be careful which one are we going to substitute that with. Okay, so we know that this one can either be 2 cos squared of x minus 1, or it can be either 1 minus 2 sine squared of x, or it can be cos squared of x minus sine squared of x. So looking at the right hand side, we can see that we have cos x plus sine x. So looking in that, taking that into consideration, we can just have our cos squared of x here minus sine squared of x. Okay, then of course this can be changed, this one, because we know what we call our identities, okay, from grade 11, and we know that anything sine squared of x plus cos squared of x is equal to 1. So let's remove that 1 there. So it's going to be sine squared of x plus cos squared of x minus 2 sine x cos of x divided by cos squared of x minus sine squared of x. Then of course we can rearrange the numerator. Then we can have cos squared of x. Then we subtract our 2 sine x times cos of x plus sine square of x. or divided by cos square of x minus sine square of x. Of course, we can now have our calculation in there because, of course, on numerator, that's already a equation which you can solve on, we know, our quadratic equations. So we can actually say that, oh, okay, this is already easy for us, okay? So that will be that will be cos x minus sine x. Then the other one will be cos of x minus sine x. Okay, let's see if it's corresponding to the other side. Yeah, that will be that there. Then on the bottom, of course, that's the difference of two squares, so that will be cos of x minus sine x, and also cos of x plus sine x. Okay, since it's a difference of two squares, so this and this will cancel, then we'll only be left with cos of x minus sine of x divided by cos of x plus sine of x. Okay, so this is amazing like this. Then this is equal to the right hand side. So we have proved that the left hand side is equal to the right hand side, just like that. Okay, please don't be hard on yourself. Take your time and take step by step. So we were able to see that, okay, this is a double angle, we converted it. We were able to see that also this one is a double angle, we converted it. So it's so important for you to be able to realize that these are the double angles and this is our special identity. So we converted that one and we use the identity form, then we're able to have the correct answer. Okay, then we are done with that question. Now let's move on to the last question so that we can have our 28 marks. Wow. 5.5. Determine the general solution of cos x minus sin x equals to root 2. That's easy. So we're given cos of x minus sin x is equal to root 2. Then they say determine the general solution for that. That's approximately 5 marks only. So where do we start? What do we do for that question? How do we solve that question so that we can have a correct answer? Just do this. Here we go. Great. So how can we solve that? Okay. So we can actually see that if we divide both sides, mm, let's see. Let's divide both sides by root 2. So that will be 1 over root 2 cos of x minus 1 over root 2 sine of x equal to 1. Okay, that's the first step, and we know that 1 over root 2 is the same as cos of 45. This question is so tricky, but that's the same as cos of 45, so we can say this is cos of 45. Of course, this is a special triangle for 45 for guys, if you didn't remember. This is 45 45. This is 1 root 2. Okay, so we can see that 1 over root 2 is cos of 45 times cos of x minus, of course, this can now be our sine of 45 again times sine of x equal to 1. So this is now our compound angle. So excited that I was able to see that. Then now we can able to see that this is for cos, so this is going to be cos of 45 degrees plus x equal to 1. Okay, then of course 45 degrees plus x is equal to cos inverse of 1 and cos. Then after that we can able to find the answer there, so that we can have a correct answer in that equation. So we can see that that will be what, let's say inverse of 1, that's 0. So that will be x is equal to negative 45 plus 0. This is 0. So our general solution, since this is for cos, is going to be x is equal to negative 45 plus 360 degrees of k, where k is the element of integers. Then after that we are done. Okay, this is so easy and straightforward. Okay, so this is how we solved our general solution. So this one wanted us to think. So the first thing we did, we divided all through by root 2 so that we can be able to solve our question properly. Now let's look at the next question which we have, which is talking about trigonometry. Oh yes, we have functions. Oh my word. Now draw the functions of g of x in your special answer book on the same axis. So this is already easy, guys. So you just use your Casio calculator, then you press mod, then you press uh mod, then you press 2, but this one says 7, where you press where it's written table, then you write your function cos of 2x. Then, of course, where is our function starting at? Our function is starting from negative 180. So when it's written start, you write negative 180. When it's written end, your function ends at 180 as well. Okay? Okay, I thought you're seeing my screen. So you're using our Casio calculator right now. So it's ending at 180. Then the step, let's look at the step which was used on the function which we have here. So they were using 45. So the step will be 45. Then here we are. So here are your coordinates which you're supposed to draw. So you just draw this coordinate. When it's negative 180, it's 1. When it's negative 135, it's 0. Then you just draw your graph just like that. So drawing the graph won't be easy. Write down the period of g. What will be the period of g there? Of course, the period of g of x, we can actually see that it's starting from negative 180 to 180. So in other words, the period of g in that question will be equal to 180. Okay, let's just write question 6. So 6.1, we show how to draw it. So we say that we say mod, we say 2, then we write our function. It starts from negative 180, it ends at 180. The step is 45. Then bingo, you have your coordinates of the function. Then you plot it. So now on 6.2, they're asking what is the period of the function? So the period is how long will this function run? So we can actually see that it's starting from negative 180, it's ending at 180. So the period will be 180. Period will be 180 degrees. 6.3. Now on 6.3, write down the new equation in the form of h of x if f is moved 3 units up. Where is f? So f of x is going to tan x minus 1. So now it has been moved 3 units up. So this is already easy for us because when we say move 3 units up, which means we must change the value of q. So we are having f of x is equal to tan x minus 1. Okay, now h of x is the graph which has been shifted 3 units up. So this will be equal to tan of x, okay, minus 1 plus 3 because it has been shifted up. So when it has been shifted up, we add 3. When it has been shifted down, we subtract the value which you are given. So we are just playing around with the parameters of q alone, okay. Then after that, we have our h of x, which is equal to tan x plus 2. So you can actually see that this is nice. Functions are so easy and straightforward. Now let's proceed. 6.4, use your graphs to determine the values of x for which cos 2x is less than or equal to tan x minus 1. So this is just trying to confuse you. That's trying to just say that use your graph to determine the values of x for which cos of 2x is our function g of x, which you have plotted in 6.1, and tan x minus 1 is our function which you have plotted above when we were looking at f of x. It's already the function which has been plotted. Okay, so in other words, I'm sorry guys, in other words, you can actually see that you can actually solve this problem, or you can actually just see it. So me, I'm able to just see it, even if it's only 3 marks. You can be able to see that, okay, this is g of x, this is our f of x. So when we look at the plots, we can actually see that between negative 135 degrees, which is less than or equal to x, less or equal to negative 90 degrees, because we are also given the interval from negative 180 to 0. Which one, where on your graphs will you be able to see g of x less or equal to f of x? Okay, so I'm saying that from negative 135 to this point, so that's where they are only equal. Okay, now let's go to 6.5. Use your graph to solve the following equations. Cos b plus 1 is equal to tan 1 over 2b. Let's solve this. 4 marks. Let's solve this question first. And it's 12 marks. Okay. So when we're solving this question, we can actually see that, okay, cos b plus 1 is equal to, what do they say? It's tan 1 over 2. So if we let b to be equal to 2x, okay, because they're saying hence, which means you're using what you already have in the beginning. So this will be cos of 2x plus 1 is equal to tan of 1 over 2 times 2x. Okay, so that's already x there, so that would be cos 2x plus 1 is equal to tan of x. Okay, then of course that will be cos 2x is equal to tan x minus 1. Then after that you can actually see that, oh okay, we can actually solve this. So when we are here, we can actually see that where are these two functions equal, because this is our g of x, okay, and this is our f of x. So now on our graphs, we just see which x values are these two graphs equal exactly. So we can see that when x is equal to negative 135, these two functions are equal. Also when x is equal to 45, okay, they are also equal. So what you do, you just now substitute 135 there, and you also substitute 45 there, then you can get your value of b to be equal to 270. Another one, x will be equal to 90, okay, because we say that let b be equal to 2x. So b is equal to 2x, so we just substitute this. So this one will be negative and this one will be that. So this is just straightforward like that, and I hope you enjoyed that section of trigonometry. Of course, we have the last section, which is quite challenging, but this is not really challenging. Let's just look at it fast. So now in the figure below, OA is the vertical tower and the points K and T are in the same horizontal plane as A. If the foot of the tower, AOK equal to X and that equal to that. Now they are saying express AK. Where is AK? Okay, there is AK in terms of the trigonometric ratio value of X in the two different ways, and hence or otherwise determine the length of KT. Why do they love making our lives difficult? Now let's check something. In triangle OAK, do you see it? In triangle OAK. Okay, so let's try writing that. So this is our question number 7 on trig. So 7.1. Okay, we start by saying triangle OAK. What do we see in that triangle? We have that value of x, we have 90 degrees, so we can actually use our sine, we can actually use our trig ratio. So we can literally write this below and say that first thing which is important, sine of x then is equal to AK over 2. Then therefore AK is equal to 2 sine of x. Then also in triangle KAT, what do we see there? We can see that if we use our sine rule, it's going to be AK over sine of 2x is equal to KT over sine of 90 degrees plus x. Okay, then after that we can make AK the subject of the formula. So AK will be equal to sine 2x times kt divided by cos of x, because that's a co-function there. So then we can see that, oh okay, this is quite nice and this is quite easy because we now know what's going on. So this is 2x, so then for we can say 2x 2 sine x, aka we have solved it here, is equal to sine of 2x times kt divided by cos of x. Okay, so cross multiply that, that will be 2 sine x times cos x equal to sine of 2x times kt. This is also sine of 2x equal to sine 2x times kt. Then we can see that kt is equal to 1 because we divide both sides by sine 2x. Then we are happy then. We are happy. I am living a happy life. Now let's do this. Show that AT is equal to cos 3x over cos x. How can we show that? This is easy because if we can look in triangle KAT, okay, which we have there in triangle KAT. You can see that we have 90 degrees plus x, we have 2x. So we want to show that AT is cos 3x over cos A. So everything is already easy there because we can actually see that the angle TAK, we can say the angle TKA, I want us to have the angle, the other missing angle there, okay, is equal to 90 degrees plus x plus 2x minus 180 degrees, okay? Then after that, we can end up having that angle TKA to be equal to 90 degrees plus 3x, okay? Then we are happy. If you are happy and please press subscribe. Then yeah, that's that for that question, guys. Then we can actually see that okay, now we know that this is 90 degrees minus 3x, okay? Then now we can use what we know and we can actually say that AT is equal to cos of 2x plus x divided by 2x. Then now, sorry, cos of 2x, then that would be AT equal to cos of 3x divided by cos of 2x. Then we're done on that question. Now, the last question on trig. Uh, simplify that into a simple trig ratio. Then you can simplify that. Of course, we start by expanding it and we work on a compound for a compound identity. And after that, we can break it down. Then you can be able to get our answer as a simple trig ratio. So actually, this question had 51 marks. That's crazy on trig only. Okay, because the first one was 28, 28 plus 12 plus 11. Yeah, it was 51, which is almost one third of your final mark. So you can see that this trick was so easy. Have a nice day, guys, and I hope you enjoyed this recording session.